Example for recurrent neural networks. So far, we've read in our data and we've also then split it into a training set and a test set, and then we actually scaled our data. So what we're going to do now is we have to figure out how we're actually going to feed batches of this time series along with a label. And it used to actually take a lot of manual effort using NumPy to make sure that everything was formatted correctly in order to feed the batches. Because the recurrent neural network, basically what it wanted was something like this. It wanted a time step 1, time step 2, and then time step 3. And then it wanted some sort of label for time step 4. And the way this worked with Keras is it just took a lot of manipulation to transform your normal test array into formatted batches that looked something like this. Luckily, we no longer need to worry about that because Keras has a whole pre-processing time series generator object that does this automatically for us. And it's a big lifesaver, so we're going to learn how to use it. And luckily, once you know how to use it well, you should be able to run this project on essentially any time sequence that you have. So we'll say from keras.preprocessing.sequence import the time series generator object. So just go ahead and tab autocomplete that time series generator from keras.preprocessing.sequence. Recall that we have our scaled training data. So all these values fall somewhere between 0 and 1. So you can see here the minimum value, and then somewhere along the lines, if you keep scrolling down here, eventually you'll see some sort of max value. So here it is for 1. Now, recall that for our scalar object, we only fit towards the training data, which means if the test data had an item or label that was larger than the max value of training data, it will actually fit to be above a 1, which kind of makes sense. So if we come back here, essentially the last 12 months, that's our test data set. And there's definitely a value here in the test data set that's bigger than the max value in the training set. So because we fit our scalar object on the training set, if I call scaled test, then I would expect to have a slightly larger value than 1. Keep in mind, that doesn't ruin anything. The main point of scaling the data is to make sure everything is roughly in between 0 and 1, or around the same scale. It's not a big deal that the scale test data set has something above a 1. So if you see that while you're playing around with the data set, don't worry about that. It won't affect the actual training process. And again, the reason we only fit on the training data is because we essentially don't want to cheat and assume future information about our test data set. So this is kind of for fairness of evaluation of our model. Okay, so we have our scaled training set and our scaled test set. Now it's time to define this actual generator object, which is going to be able to read in an entire time sequence like scaled train and then spit out batches. So we're going to be playing around with this quite a bit to actually explain what's going on. So I'm going to define two variables here. I will say n underscore input is 2, and then n underscore features is equal to 1. And then I will say my generator is equal to time series generator. And if you do shift tab here, you'll be able to see the actual results of the time series generator object, as well as all the different parameters it can take in. So essentially what this class does is it just takes in a sequence of data points gathered at equal intervals. So that's an important part. In order to use this, they have to be done in equal intervals. And we have time series parameters like length of history, stride, etc. And essentially we're going to work through a couple of these parameters. So here's our generator object. We're going to pass in your scaled training data. And you essentially pass in the sequence twice. So that's kind of a little interesting, but essentially the source of the data and the source of the targets, the way we're using it here, should come from the same data source. So what I mean by that is, recall I said we want something like this, T1, T2, T3, and then T4. So if we look at our scaled test set, that would be kind of these first 3 points are used to predict this 4th point. And so the source of both the first 3 and this 4th point are coming from the same scaled test or scaled train. So you can see here we have scaled train, scaled train. So just want to show you kind of the beginning of scaled train, since that's what we're using right now. So we see we have scaled train, and what I'm going to do is I'm just going to grab, let's say, the first 5 rows of data. Okay, so we see here the first 5 rows. Again, if you kind of scroll up, that was these 5 rows right here. So there's the first 5 rows of our series, and I said number of inputs is equal to 2, number of features is equal to 1. Let's see what happens when we say scaled train is the source of my data. Scaled train is also the source of those labels. The length is equal to n input, and later on you'll see that you'll be able to edit this n input number to whatever you want. And we'll say batch size is equal to 1. So that's all we're doing right now for playing around with this time series generator object. Okay, so what we're going to do here is go ahead and check out the length of my scaled training data. The length of my scaled training data, as we previously discussed, is 313. This generator object also has a length, and the length of that is 311. So notice that's exactly 313 minus this number of inputs. So let's go ahead and see what the generator object actually kind of produces for us. To do that, we call generator, and we can actually index directly off of this, and it returns back a tuple. So it returns back this tuple kind of in a little bit of a strange format. So what I'm going to do is I'm going to do a little bit of tuple unpacking and say x comma y is equal to this first item in the generator. So what does this actually look like? If I take a look at x, it's 0.036 and then 0.036, and notice there's a 5 and then a 4 here. Well, let's take a look back at our scaled training data. Notice the first 2 points were 365 and then 364. So right here we have x as the very first item are those first 2 points, 365, 364. And then the y is 0.082. So if we take a look here, we have 0.082. So all it's doing is based off the number of inputs, it went ahead and said, okay, that will be the length of the training data, and then we'll predict that very next point. So all we're doing here is for that first generator object, it's the first 2 points, and then predict y. Let's see what happens if I went ahead and made number of inputs equal to 3. And then I reran this generator, check the length of my scaled training data, and now check the length of my generator. Now the generator object only has 310 because 313 minus the length of the input is 310. So then I'm going to rerun my generator object, grab that first item, and now look what's going on. Now x is equal to those first 3 points, and y is equal to that 4th point. And we can confirm that by checking this out on the scaled data set. So what does this actually mean? What is the generator object kind of doing work for us? Well, what it's able to do is it's able to grab however many number of inputs you want and then produce back that very next time step. And that's essentially what the features and labels will be for our recurrent neural network. What it's able to do is you define how long your training sequence should be and then the very next point to predict. So how should we decide the number of inputs here? If you're dealing with a data set that shows some clear seasonality over the course of a year, then you should probably feed in at least 12 data points in order for the recurrent neural network to be able to pick up on that seasonality. So keep in mind, the larger the number of inputs here, that means you're going to have way more features, which means you should probably have a larger network and the training data will take, or the training time overall will take longer, but hopefully leads to better results. So later on, we're going to let you play around with what that number of inputs should be, but hopefully you get the main idea of what the time series generator object is able to do. It's able to allow you to define the number of inputs here, and then you can see here it's predicting 1y into the future, which is pretty much exactly what you want. You want to feed in a sequence and then predict 1y step into the future. And then if you want to predict more than 1y step into the future, you just keep repeating that process, and eventually you'll be using your forecasted values to forecast even further into the future. And that's what we're going to see in the next series of lectures when we talk about creating the model and forecasting into the future. So we're going to first start off by forecasting into the test set, and then you can essentially use the exact same process to forecast as far as you want. But for this lecture, the main thing I want you to realize is we have this very convenient time series generator object which formats everything for us. And you notice that the formatting is actually quite complex for the shape of X. Notice it's actually 3-dimensional, and that's what's needed in order to feed in these little batches of time series information into the neural network object. So that's why it's usually quite complex if you were to try to do this by hand using NumPy. So instead, we use this time series generator object, and now you should hopefully be able to see that you could just fill in your own training data, fill in your own number of inputs, and then fill in the batch size. So what does batch size actually mean? Batches is just how many time series batches it produces. So if you kind of start playing around with batch size, so if we say 2 here, and we run this again, then notice what the shape is of x. So now if I take a look at x, it's kind of two batches. So here's one, and then here's the very next one forward, and then here's y. So again, it's essentially just two of that first one, and you can keep increasing that. Typically for recurrent neural networks for time series analysis, smaller batch sizes leads to better training. And in fact, even if you just say batch size of one, kind of just feed in one little snippet of time at a time, so to speak, that typically works really well for recurrent neural networks. If you do too large of a batch size, I think the neural network ends up overfitting to the training data. But again, there's no 100% correct answer, and you can always experiment with batch sizes, number of inputs, and just use your metrics to decide what were the best values. So there's kind of a lot of testing you can do in your generator object to get the best results. Okay, so that's it for this little kind of quick lecture on what that time series generator object is doing. Up next, we're going to create an example model. We will go ahead and fit the generator, and then we'll evaluate on some test data and show you how you can forecast into the future. Okay, I'll see you at the next lecture.